Okay, Roy, what are you going to show us here?
Well, we are showing how to collect solar energy or wind energy, or it could be wave energy, or for that matter, it could be hydro, an in-stream hydro energy conversion to electricity. And we're making electricity here and applying it to two electrodes, across which then we dissociate water and produce 2 parts hydrogen, 1 part oxygen. We're saving that hydrogen then at pressure. We're showing how to build pressure. And you can go right to storage. You could be fueling this vehicle or any vehicle with the pressure capability of such an electrolyzer if this was built into the size for the purpose.
So here's the electricity source. In this case, it's a solar panel.
In this case,
it could very easily be this Tessie over here.
Could be that, or it could be a gymnasium with people becoming physically fit as they power a generator.
And here is the little electrolyzer, which is converting electricity. The water's going in here and it's being converted to hydrogen and oxygen from the electric source.
That's right. Now this grows into a unit that's about the size of a washing machine to be able to fuel 2 vehicles plus your home with hydrogen.
But not off of PV.
Well, it could be off of PV, it could be off of wind, it could be off of any source of electricity. It could be off-peak electricity from a conventional power plant to improve energy utilization.
The key thing with PV is the current price of manufacture makes it, you'd be driving around $30 a gallon hydrogen.
Well, wherever you have PV, you can make this an incremental event for when there's surplus PV capacity and it isn't $30 a gallon, it's whatever that incremental cost is for something you've already installed.
So it's good when you have surplus PV.
Well, it's good for when you have PV that meets your peak needs and you'll have surplus in between peaks.
So one of these is going to be hydrogen and one's going to be oxygen.
That's right.
It's bubbling up. There's a weight on top holding it to pressurize it.
These are the heads that are being produced by pressure. What I'm going to do then is bleed some water off of the other fuel cell, which will operate in reverse then as a...
So these two are the same.
These are exactly the same.
Fuel cells, but this one's being run in reverse as an electrolyzer.
That's right.
And this one's being run forward as a fuel cell.
That's right. And what I'm doing is bleeding off water. You can see it, and I'm clearing the electrode enough to produce some electricity across it in its reverse mode. And I just cleared the air that was actually in that line, I noticed, and bled off some water that had been accumulated. Now I'm going to accumulate a supply of hydrogen and oxygen again. Because there's no wind, then this will become a motor.
Right.
In the instance of driving it with a fuel cell.
Well, you're saying if there's a lot of wind, and this was big enough, this would be spinning, and they'd be sending electricity down here to the fuel cell slash electrolyzer, making hydrogen and oxygen, which gets stored in here.
That's right.
Which can then come back either to here or here and spin that, or
you can fuel your vehicle, or fuel your cooking center, or fuel another application such as a torch, a hydrogen oxygen torch, or a hydrogen acetylene torch using oxygen, or acetylene and hydrogen interchangeably with our high boost concept.
Right. Now this is a demonstration model. This unit here won't power a vehicle.
No, this is a unit that lets students discover Avogadro's number, Faraday's laws, and many other classic experiments in physics can be repeated here. And from it then you can show how to power any application with stored energy. You might look at this, for instance, as the Dakotas. This is the Arizona or California desert. Between the two are depleted natural gas fields where you're recharging with hydrogen.
And over here, the motor spinning is our lights in our house or whatever we want.
That's your factory, that's your farm, that's whatever it is that you may want to continue the industrial revolution on a sustainable basis using renewable energy from any source.
Okay.
And using the infrastructure that we've already developed around the depletion of fossil resources.